Lecture 11 covers sections 3.9 and 3.10. At the end of today's lecture, you should be able to understand the concept of enthalpy and be able to determine any enthalpy value from the steam tables. You should also be able to understand and apply the formulation of constant pressure specific heat. For us to begin, let us recall our conservation of energy equation. The change of energy is equal to our heat supplied less our work done. If we ignore kinetic and potential energies within our system, and we express work in terms of our pressure and volume, we can say the change of our internal energy is equal to our heat supplied less the integral from state 1 to state 2 of PdV. Now, if we have a constant pressure process, P comes outside of the integrand, and we'd have merely the change of volume. Thus, we can re-express our conservation of energy equation in terms of our heat input. That is, delta Q would be equal to du plus PdV. Now, if we express this in terms of change of properties between our initial and final states, we can say our heat supplied going from state 1 to state 2 is equal to the difference of internal energies between state 2 and state 1, plus our pressure times our change of volume between states 2 and state 1. Since our pressure is a constant, we can say P is equal to P1, which is equal to P2, where P2 corresponds to V2 and P1 corresponds to V1. Thus, we can re-express our heat supplied going from state 1 to state 2 as our internal energy plus our pressure times our volume evaluated at state 2, less our internal energy plus our pressure times our volume evaluated at state 1. Since our internal energy, pressure, and volume are functions of state, i.e. they're point variables, their summation also has the same characteristic of the state, i.e. it's a point variable. Therefore, we will define enthalpy, denoted by variable h, as another extensive property. And enthalpy is simply the sum of our internal energy plus the product of our pressure and volume. Or on a per mass basis, our specific enthalpy is equal to our specific internal energy plus our pressure times our specific volume. Now, note enthalpy is merely a tabulated value. For instance, you can take a saturated liquid or saturated vapor specific volume, multiply it by your pressure, then add it to the corresponding saturated liquid or saturated vapor specific internal energy, and you will have your saturated liquid or saturated vapor specific enthalpy. A very interesting consequence of our formulation of enthalpy is for a constant pressure quasi-equilibrium process, our heat supplied is merely the difference of our enthalpy between our final initial state. We can only use this for a constant pressure process. Enthalpy is tabulated and is a function of two independent properties, such as temperature, pressure, specific volume, specific internal energy, or quality. Specific enthalpy can be calculated just like specific volume and specific internal energy. That is, we can calculate our enthalpy based upon our quality, our saturated liquid specific enthalpy, and our saturated vapor specific enthalpy. And just like we've done before, for our specific volume and specific internal energy, we can use our saturated water temperature tables to use our temperature entry value for our corresponding saturated liquid specific enthalpy value if it is not published on our compressed or subcooled water tables.